Thank you, Chinu, for the intro. We wrote that. Nice. Uh, so I'm going to talk about visual testing of the labs in an headless environment. A lot of words, heavy words. But before we proceed, how many of us know about what is a headless environment? Right. Yeah, it's just basically an environment where you don't have any display, no head. You're sort of moving in the dark, and now, and this is not about any particular or any technical overview. It's more about a journey of a team who discovers the need for a visual testing and how they achieve it, right? So, as for any journey or a story, right, we need to have a premises set. Yeah, sorry. So the Prometheus is a team alpha who wants to build a perfect web application, right? They have very high hopes, they have very high standards for themselves, right? They want it to be perfect, a stellar app. People should be in awe when they like, this is the best app ever, right? And they want the users to be unparalleled. They want people to stick to their app. That's what we all want, right? That if someone comes to my app or my website, they should not move any time away, right? And that's all is good, but then when they come to the crucial part, right, about how you have to release it, right? The key to all the success is a robust app, and the way we are going to so it becomes a brand value for you. So the questions go around. Like, how do we ensure that we don't, what determines that my product is a robust? So we don't break things. We have all those test pyramids over there, which we have all seen, right? The unit test, the integration test, right? And so the team also think we have UI test, right? I know when the user clicks on login button, it will log in. We have all those tests everywhere. And then someone says, that's fine, but how can I ensure that when my color theme is intact or the way I align my text boxes, how do I ensure, how do I test that all my text boxes are exactly where they want to be, right? How can I ensure that the images which are supposed to be of certain sizes are of same size, right, for each and every commit we make? How do we ensure that? So, and then the team did not really have any answers because none of them fit in this paradigm, right? The UI testing is not very obvious in that sense. So then the team said, okay, let's take a look about it. They said, okay, a bit of Googling also will give them the same answer, but then they said, okay, here's what we'll do. For every commit or for every regression you do, we will take a snapshot, right? And we'll compare it with the previous snapshot, right? So the first step is to understand or ensure that you have a baseline set, right? And what happens is you go to a screen, you take a snapshot, you save it somewhere, you get it reviewed by your UX designers, your VAs to see that if things are in place or not, right? And that becomes your source of truth, or the golden image is what you can say, right? They are gold, they are valuable. Then, with each successful pass, what you will do is you will repeat the steps, but the one step is added away. It's when you compare them, right? You would compare your current snapshot to your previous snapshot, right? And if they are identical, you will say, yeah, all is good. We are good to go ahead. Or if there is any difference, the system should say, blah, we cannot go forward. And it's very straightforward, it's very simple. It sounds so intuitive that it should work out of the box, right? And so the team goes ahead and does some setup, right? How many of us here has experience with the CI/CD setup or environment? Do we all understand what is CI/CD? Is it fair? Right? Sorry, I'm not happy of this. So yeah, so now there is a CDS system. An example is a gate over here, but it can be purpose, SVN, whatever the team chooses. The code is submitted to the system. My CI/CD system goes ahead and makes a build out of it, right? That's the point where you would go do a normal your unit level testing or the critical quality gate testing, which you do, right? Because beyond that, the build is of no use. So you test everything over there, bit out a build, right? Then you go ahead and do a functional testing. The function is the one which we have talked about, right? The testing of your regression scenarios using Selenium or whatever tools you want to use. Now, and then you have your visual testing, is what the team decided on. Now, if you see, there are two kinds of infrastructure requirement involved over here, right? Or I would say there are two kinds of identifiable requirements over here. One is you need your agents which have some displays, right? Because if I have to run some tests like probably a flow path test, the Selenium test, or if I want to do visual comparisons, I would need agents which have at least displays, right? Where you can do visual comparison, right? While I can also have a very lightweight systems or agents somewhere, like even in a virtualized container or somewhere, which can build, right? For building any of my artifacts for testing, I don't need any display, right? It's just a simple command, like some command which I would script up, right? So these are two kinds of things. Now always, the money is always involved everywhere, right? So buying or procuring such agents which have displays is going to be a lot more expensive than going in a very serverless headless environment like some virtualized services like AWS or something, right? So that's one thing the team noted. Like, okay, we have this kind of setup. That also means I have to now maintain two different kinds of agent configurations, right? Both may not be identical because the way the hardware also different. But everything is there, all looks good, but then one does not simply do image comparison. Alright? What happened on ground is the tests were failing left and right. Some of them would pass, some of them would look identical, but still they would fail. The team was in a fix. Why? The image comparison was done using image magic, which is the golden standard of comparison. The snapshot looked same with the naked eye. I mean, it didn't have any differences. Then why there is failure? And the reason was, what the team thought was, oh, my tooling is insufficient. But then the tooling is what we already is a proven thing anyways, right? So the team thought, okay, let's dive a bit more into the nitty-gritties, see things. So when we do image comparison, the things in play are the pixels, right? And if I elaborate more, it's pixel per inch, right? It's a pixel by pixel comparison, and it goes to the minute details of what exactly is the point drawn in the display and what constitutes that to be image. Now, mathematically, you can find out a pixel per inch in a formula over there. It's basically the width and height of my display, my resolution of my display, let's say 1224 by 768 is my resolution, divided by the size of my display gives me the pixel per inch, right? So, okay, mathematically good, but then again, where is the failure? Here comes the other part, right? For a 13-inch display, for the same resolution, I have 98.4 PPIs. Similarly, for 15-inch, the PPIs are different, while for a 17-inch, it's again different, right? Apart from that, do notice that the PPIs are not whole numbers. It's basically 85.33 PPI leaves that bit of gap where it is now a manufacturer's domain, where the manufacturer can either round off to C or float, or in fact not even round off and just try to compute the density or the luminance of those spaces, right? And image magic being such a robust and cool tool, it figures out that, okay, there's a difference, right? Now one hacky way, I would say hacky, is to go ahead and add that, okay, I have a fuzz factor over here. I am okay to say that 5% of my fuzz is acceptable to me. Yeah, I understand. Things are not that good. And it didn't pass for that iteration, right? But let's say tomorrow you have a much more complex screen, right? And that time, now 7% is what becomes the acceptable thing, right? And that's what happened to the team. They said, okay, we all want to move fast. We all want to not delve too much into these nitty-gritties and move faster. But then even the first factor becomes unmanageable at the moment of time. That means if at a point a 10% first acceptability is for one screen is an error scenario for a second screen. So the team took a step back, said, okay, I understand PPI is going to cause me some certain discrepancies. So what if I could make PPI a constant full number, right? But PPI is not software. It is not something you can control, right? PPI is determined by your hardware, the display, and it is coded into the displays, right? So how can we program the hardware display? Unfortunately, you cannot. I would recommend not to, even if you can. But then we went one step ahead and see, okay, what is my flow of an image from the way I'm reading it to the way it is rendered on the device, right? And it turns out it's a pretty straightforward thing to visualize, right? Every system is a GPU, right? Who actually creates or determines the data which needs to be processed and pushed, right? There is something called the frame buffer. Have anyone heard of frame buffer? Yes. Right? So a frame buffer is nothing but a bitmap kind of thing. It's a huge array of bits, and it is stored close to the GPU for now. It's a modern architecture now, so it's close to the GPU, and it puts all the data into the bitmap, and then there is a digital to analog conversion, which then takes this bitmap and pushes the device, and that's how you can see all those beautiful images on the device. Right. Now, one may argue again, why go in this direction? Why not Phantom JS? Why not the new headless Chrome, headless Firefox? Why all those? Why go in this direction, not in that? So the team decided that first, we don't want to rely on any browser-specific APIs. One. Secondly, there are conditions where the headless will not work out of the box. You would have to code anyways. For example, if I want to take a full screen screenshot on the headless Chrome, it needs a bit of coding. It's not directly right. All of them provide you to give a viewport. Right. I want to take a snapshot of width, height, and that's the domain of your image, right? And you have to code along with it. And that's what I'm talking of the API of the browser. Right? We don't want to tie ourselves to the browser as yet. The moment they evolve, yes, probably we should. So, to go towards a browser agnostic mode is when this research came into picture. So, this is the next step. XVFP. Any one of us have heard about XVFP? Yeah, thought so. So it's a virtual frame buffer, right? Imagine the same frame buffer thing, but it is not tied to any device or any display or any of the GPU. It is just a contiguous allocation of memory, a bitmap in RAM, right? This XVFP is cool, it's very cool, because it implements the entire interface of your frame buffer. That means whatever a GPU uses to communicate to the frame buffer, right? All of that is implemented by XVFP, and that means I can just launch my XBFB at a certain display port, and my GPU would not know that it's not an actual display, right? As well as, since it implements those interfaces of a frame buffer, I can very well export certain ports on my device, on my system, and do my VNC, screenshots. So the entire system is unaware that there is no actual display. It's just a proxy process which emulates a display. But more importantly, since it is an emulation, it means that it gives you capability to do a screenshot, to even VNC into it. So again, then we took this case of XBFB, and now we are able to do this. We are able to start an XBFB process with a fixed resolution and a fixed whole number PPI, right? That's the important part, the fixed whole number PPI. That guarantees that each pixel of a same image taken 1,000 times is going to be exactly same. Alright? So you do this, you start an XBFB browser, XBFB agent. Now you have launched your application or browser. Again, since the system level abstraction is there for the frame buffer, when browser thinks that yes, I am running on a display. So each browser, you can launch all of your browsers, Microsoft, Firefox, Chrome, Opera, whatever you want to, right? Execute your visual test. Now, when I say visual test, right, what constitutes a visual test? It is nothing but a regular functional test with one step to actually compare. That's it. There is no specific or a different specification for a visual test. It's a normal, any other test, but just with a comparison step, right? And you leverage your current setup of your automation to report it, right? But now the things were set up fine. The team is quite happy. But then again, where do they start this process? Where do they start the XBFB? How do they control when my XBFB starts, when the VNC starts, right? The flow of the control to all these things. This means, if you think about it, it means I have to provision my system under test every time, right? Copy the latest XBFB, ensure it starts. There are a lot of checks which have to be done on each and every device, right? This hinders the repeatability process, because we are human. We try to go and debug on the agents also. Right? We leave our traces that Manish was here. That means I have some dummy files, some of my magic exes or stuff lying over there, and over a period of time, my agents tend to become snowflakes. So when I say snowflakes, that means yes, they would in the end become certainly different than each other, and which may again cause some flakiness in the system, right? I had my super EXEs, which does some extra logging, but then hooks into certain APIs and does that. And somehow I forgot to remove it. It's lying on the agent, and then someone's jobs get picked up. It uses that EXE and then produce totally different results. And the person will be scanning his head, what happened? This should work, right? So good is a wrong word. A great test suite or an agile test suite must be a repeatable, should give the same result every single time, right? And it's no exception to your visual test. It should produce exactly same result every single time. The only time this is an exception is obviously when there's an actual error, right? So, like I said, the team took step further. They understand that we are creating some snowflake agents, and it's all about, I want to repeatability should be there, and there should be no flakiness in the system. And the solution the team thought is, let's containerize the entire thing, right? Anyone who can talk about containers? Do you know what containers are? we all know about Docker over here, right? At least heard of it. Okay. So the team chose Docker, right? The Docker is different than the other virtualization softwares, right? Because the key difference is there is no virtual machines over here, right? It's an OS level virtualization, right? It uses the same exact hardware which is there on your host machine. It's basically a set of files. It's a file system, a base file system which is based on a Linux container tool set. It's simply put, it's just a set of tools which is used to mimic a OS file system. You can put your requirements. Let's say for my web app to run, I need Java, right? So I can install a JDK on that Docker. It's in any other image. So each of these tools which I add are added as a layer, but to the host system, it looks as if it is a unified single layer. And actually, the file system is called unified UFS, unified file system. The Docker says that. And it's a simple client server architecture. You will see more about it in our workshop. But essentially, you start a Docker server, right? You request it to start an image, and once the image is started, I would run my test in that environment, in that sandbox, and I bring it down once I'm done, right? It's repeatable because there is no way I can change the image at runtime. The image is created once, pulled in, and executed, right? So I can do it 100 times. I can go ahead, I can go and write, put all of my super hacky EXEs in there, but the moment the test is completed, it shuts down, the images are gone. Next time you spawn out, it's again a very fresh one, right? So that adds to you one robustness and the repeatability part, which is the essence of writing automation, right? So how do you use Docker? 3 steps: create, share, run, right? First it. So you create an image. Whatever you feel is prerequisite for your test to run, you bake it into the image. So that means, let's say I need JDK, I need Selenium, I need image magic is obviously I need to for comparison. So I would create one image which has all of this. I'll share this image in a place where all my agents can pull from, right? It can be on the cloud like AWS or something, S3 repositories, or I can keep it in local file system also. And then I run it. Now, an ideal practice of Docker is you take your image, right? You load that image into your server, then you say run this image, but you don't bake into your code. You don't bake your code into the Docker image, right? Because like I said, Docker is a fixed set of hosts. It's like a Windows system on which you then put your files and work on it. So similarly, when you want to run a Docker image, you would basically mount your code files and execute certain scripts on that. So that's the create, share, and run. Right. So they came up with this final setup. They have a pipeline which creates a Docker image. It's not touched at all because who changes the tech stack every other day? No one, right? So it's when they change or they control the versions of their tools is when the Docker image is created and it's kept safe somewhere. So now the setup is fetch a Docker image. If that same image is not present already in my agent, then check out the code from whatever your CVS is, right? If you want to do, you build it, or else you can also optimize it further, right? I have a pre-built sanity check build somewhere. I'll download that build also. I'll start my Docker image, right? I'll run my test over there. And this setup is not just restricted to visual testing, right? It can be any of your tests which you can Dockerize actually, right? I'll report to my CI with successful failure. I'll stop the Docker image, and that's it. Repeat, rinse and repeat, right? So, in a nutshell, what did this alpha team achieve? Right? it achieved or it created a persistent headless environment, right, which runs and builds in all the tests. That means that the cost of maintaining a separate class of agents is no more there now. If you understand, right, if you go back, there was one class of agents which were like on AWS, Linux boxes, lightweight, while there was other set of agents which were like, let's say, some desktop boxes, right, with displays. So they have now removed the cost of that and they are into a single homogeneous environment, right? In fact, they even moved it to totally virtualized environment. So let's say it's data center, AWS, everything was moved to that data center. So even you launch a container, then you launch a Docker, and everything goes spin up, spin down, right? So no more flaky tests, no more flaky visual tests also, and very high repeatability. So in fact, the correlations are not now about the flakiness. It's about, okay, if there is red, that means something is really faint. You don't worry about, is it the image merging again, or is it that what was the resolution of the device? It's no more that conversation. It's about what failed, right? Like I said, then the infra was fully reusable. There is no compartmentalization of any of the tests, and so I'm sure the question would have come post this session that what about the tools ecosystem available, right? You have a lot of different things like browser stack and all doing all these things for you, and can you use that? You can obviously use that, but then it's a specialized system again in themselves, which comes at a certain cost, right? And since the team already had a CI/CD in place, why would you go and add cost to yourself? You would not, right? Now, since this is set up now, there is even traditionally the wait was for you, the developers to wait on QAs to say, hey, do you see this is amiss? Do you feel that? And what about how does it match specifications? All those feedback is now part of the pipeline, and the QAs can now actually focus on actual exploratory testing than looking about the spec. Because if it is a green pipeline for me, the specs have passed. Alright, so that's the time saving there over there. And also obviously they will have rate reviews if everything is good. So that's the key takeaway from that. Now before I stop, or before actually I missed everything, but yeah. So before I stop, I want to point out that who is this team alpha, right? So this is so when I was listening to Vishal over here, it felt so organic to think about it. And Team Alpha is not about developers or QAs, first thing. Right? Who do you think has made this solution? Do you think it was the devs? Do you think it was QAs?
DevOps.
No. It was Team Alpha. There is no QA, there is no dev when it comes to problem solving. The problem solving is or I would say it's the responsibility of each and every member of it. If it is about QA, even a BA would give you valuable insights. And once you start socializing it, it's about the problem, right? So, for me personally, never think about, okay, it's about test. Probably a QA should look at that, right? A dev easily would have put his hand up and said, okay, I am giving you an artifact. You have to test, right? But that's not what a quality focused team would do, right? And the key, I'm sure there would be very few devs over here. Are there any developers over here? Yeah, I know, I knew. But yeah, if they were devs, I would have said that it's about the solution. Always think about what you want to achieve, and the common goal here was not about Dockerizing anything, creating any, saving any money on the infrastructure. The common goal here was creating an awesome product, right? And that common goal is for everyone. That's all I have. Thank you. Any questions? Yes.
So I am. This is more related to the Docker. So like I am very new to the Docker thing. So like it's going to my next thing to learn. So like I want to know, is it like just for the Linux and the headless environments, or I can also go for like the other Windows OS versions and like the Chrome browsers and then.
So the question is, not heard. The question is about the usage of Docker per se. Is it only contained to Linux?
Yeah, and the headless browser.
Or headless. Okay. So Docker is actually an integral part even in the deployment, in the production use case. Right? A lot of companies are moving towards deploying their production artifacts and exposing to the open world in Dockerized containers, in Kubernetes sort of thing. So it is sort of a de facto standard when you want to have a repeatable, controlled, and robust instance, right? Now, our use case was about headless testing, but like I said, I can do it for even building my artifacts. I can use it to do anything I want. But the key here is about the cost. If I can build something on a normal host machine, right, in 5 minutes, let's say, I'm just putting 5 minutes, it's wrong, it's very bad thing to build in 5 minutes, but let's say I put 5 minutes, right, I would pay, okay, to repeat that bit in Docker, right, unless I have a very specific set of tooling which needs to be provisioned very often. Docker needs to be downloaded, right, spun up, build something, and then spun down, and also, right. So I would argue about the use cases. The use cases is what you think that it's all about you can imagine whatever you want to do on Docker. It's just about thinking about the cost of the entire process.
So can I imagine Docker? So like when I boot up a Docker, can I imagine it as a replacement of a remote machine or something?
So the question is, can Docker be a replacement to a remote machine? That depends on what. I'm not sure if I get what the remote machine is, but I understand that when it's a remote machine, that means a remote setup where you go ahead and do certain scenarios.
Yeah.
Yes, for that bit, you can think of that bit.
Hi. So my question was it an app, a responsive app, and what were the complexities and how did you resolve those challenges?
Thanks. So yes, this would be a responsive app, and if you see, so it's a simplified view which I have presented. But in ideal scenario, you would have, so once it's responsive app, that means you have different dimensions to take care of, right? And that bit of engineering is unfortunately tied to your browsers. For example, Chrome gives you a switch or a flag called dev metrics, where you can pass the resolution which you want to emulate, right? So once you push that bit with the Chrome and then you spawn up, so you are actually emulating that device. So you can emulate an iPhone or S8 and then you snapshot it. And the process is exactly the same, it's just that the metrics have to be applied to the browser. And also you would have to think about how you organize your snapshots, because now your snapshots are tied to your configurations. So probably you would need an elaborate scheme over that side that, okay, 102.768, that's my base requirement. I would test for retina display because that's the highest one I have. Samsung S8 is what I see from analytics which Anand said, right? I can find, okay, most of my site is from S8, so I would bake it into my test suite. But that's how you maintain it. So that bit is tied to your browser APIs.
So you're currently using the virtual video frame rate with different resolution functions.
Correct. So Docker also helps you to parameterize your testing also, right? So I would just set some of my goals that this is my resolution. These are my environment variables, which I can each of my pipelines would include those environment variables. So I can have a pipeline like visual test on Retina, visual test on S8, and those pipelines will break into those, the environment will be break into those pipelines. And that's why I control all those different settings.
Hi. If I understand correctly, Docker is cloud, right? It's based on the cloud infrastructure.
Partially true. Partially true. So some of the use cases is on cloud. Like I said, you have a lot of technologies over there which leverage Docker to maintain microservices also, like Kubernetes or Docker Swarm or such like that. But that is not the only use case, right? A Docker, you can install Docker on your machines. You can emulate all your Linux systems. Unfortunately, still not it's Linux, only because it relies on a Linux container toolset, so it can emulate Linux flawlessly, right? So that thing you can set up even on your normal desktop, and you can use it just like a VM also, a virtual machine also, right? So, like I said, it has various use cases, right from production to your local box development also.
So, basically my question is coming from an enterprise angle. When you download images, you have to look at security. You're talking about images which are being open source, created by open source, through that open source mechanism. So how do you look at the security angle of it? Because that's the first question that the organization came to ask me. How do you make it secure enough that your code is not going outside?
Okay.
So that's an image.
So basically, a lot of this is driven by your security consideration. That's correct, and also backed by your infrastructure. So what I mean is, you create your image. We don't use public images, first thing, right? Your public image will be your very base image published on a Docker Hub. Maybe just Ubuntu, let's say Getty image 14.04. On that, you bake your Docker images, and Docker image is something which is not supposed to be on the public domain anyways. That's your, unless your organization or your security team is comfortable that it does not contain any sensitive information, right? You would not want to have a Docker image which tries to use a service Git RSA keys and try to pull information. That is obviously not, that's insane to say that, right? So obviously you cannot save or save these Docker images outside of your org. Now once you create this, or once you make a proper image out of it, of this Docker file, this image again has to be, if this has to work in pull mode, that I pull my images, it has to again live very close to your infrastructure, but backed by certain infrastructure, an Artifactory or Nexus repository system, or probably even on AWS S3 if it is in a corporate setup, right? So we use S3 to push our images, pull, because S3, like any other repository system, our Docker image can run up to 1 gig, 1 GB, let's say. So I would not want to download 1 GB every time, right? So I would definitely use certain Artifactory repository systems which would do a SHA match and say, okay, do I want to download or not, right? So security concerns should not be a case if you are very particular about how you manage your Docker files and have some hygiene consideration in the picture.
Okay. So if you are using private clouds or your enterprise servers, does it not involve cost? I mean, how do you justify the cost then?
Good question, but it's not something I am procuring specifically for my project. It's something where the infra or the organization usually have an investment in. If I have to specifically invest for doing all this setup, firstly I'll be very surprised if if an organization does not have some private cloud setup, because that's what things are at the moment. But let's say even if I have to now invest in this setting up private repositories and clouds, I would use that then this procuring agents and then running in this non-productive setup, because in the end the time taken also is considered of importance, right? The time to delivery is also of importance. So again, I'm not very much qualified to answer about the cost, but if it was up to me, I would still, if there is no infra setup, I would still go for that, because it is a long-term solution than procuring normal agents of different resolutions and do.
Sorry, I have one last question. I'm sorry, too much of your time. See, as a financial organization, So it's very skeptical on the private cloud. It's still not on cloud. We are very skeptical. We are on the cloud part. We are okay with the enterprise servers because we are going to manage it. Because we are dealing with financial data of millions of customers. So that part of the equation goes out right then and there. Okay. As soon as we say private cloud, there's a big question. So now justifying an enterprise server, I know there are servers already available, but you cannot block the existing systems because of this process. So you have to justify the cost, you have to justify that only for testing, your visual testing, you're taking Docker into your picture.
Okay, I can quickly answer that and probably we can talk of that also. But, so what's the use of an artifact repository? It's about managing your Docker file images. Right? Now running Docker on an agent should not be a concern because it's not talking to an outside world. Is that fair enough to say? I can, if the restrictions are so high, I can even go for pushing my Docker image itself into the repository, an SVN or something. We have tried that also. Bit counterproductive again, but the trade-off is straightforward. It's better trade-off. Secondly, even if it's financials, right? I think we can still think about going for a distributed setup like OpenShift or something like that, ECS, Elastic Container Services, which is very much within the organization domain and not outside it. But then again, that's a different discussion altogether. But the answer would be you can still find the key is to find an optimized way to get an image to the agent. Suppose that you are not in a distributed system anyways. Right? That's the key.
Can I add to that?
Sure.
Yeah. I think you had major concerns around security. I think I will talk like that.
Yeah, you can talk to
it's similar to what Java libraries do, right? Your security team probably approves. Okay, you can use this jar file, not something else. You can do exactly same thing with Docker. Your security team can say, okay, you can use only Ubuntu this image, right? They can do that. Second is, as he was saying, you can set up something like Pune, which is a local Docker repository, and all your project can use only images only from that, and they can cut off the access to internet. And then whatever images you generate, whatever artifacts your Docker generates, they can keep it inside. So all of those security concerns are already kind of addressed. There are solutions to that. It just you definitely need to have conversation with security team, because of course they are like gatekeepers of your confidentiality, integrity, and all of that. But trust us that Docker has solutions to most of those situations, and there are softwares to do all of that.
Thank you so much, Shirish. Thank you so much, Manish. This was a really insightful talk. We see that there are a lot of questions around Docker and security. The good news is we have a workshop around them. So we have a workshop on Docker, we have a workshop on security, we have a workshop on contract tests using PATH. So that right after the